Imagine sitting in front of your screen. Is there truly nothing between your eyes in this display? Or is there a hidden infinity, a realm so subtle and complex that it appears empty to our senses? A topological singularity combines these ideas, a hidden dimension of infinite complexity that looks like nothing at all. A topological singularity is defined as any object that has zero measure and uncountable depth. Zero measure means any object so small, like a mathematical point, it appears like nothing but still exists. As we've learned, zero does not equal empty. Uncountability represents a size of infinity larger than the infinity we use to count. Colloquially, this is synonymous with impermanence or constant change. For a deeper dive on both of these concepts, check out some of the previous videos we did or the white paper linked below. An object with zero measure looks like nothing, meaning if we used a hypothetical perfect ruler, we'd get a measurement of 0. If we also tried to measure an empty set, we'd also get 0. But emptiness means no existence at all, a set with nothing in it, while a set of zero measure can still have elements inside of it. So how can two concepts that both read as 0 be so fundamentally different? Well, alright, imagine two doors. Door 1 leads to a completely empty room, truly nothing inside. Door 2 leads to a room containing uncountably many doors with zero measure. Essentially, for every door that you pick, I can always pick a door that you didn't. From the outside, both rooms appear the exact same. You can't detect any differences using conventional means because they both look like 0. Simply put, you can't tell which door hides nothingness and which door hides an uncountable infinity. This scenario highlights that zero measure can conceal immense complexity, whereas emptiness truly holds nothing whatsoever. Both look the exact same. In our previous video, we introduced the concept of an idea space, or your mind. Like the object behind door number 2, your idea space has zero measure. No one can directly observe or measure it, yet it's uncountably infinite. Thoughts, emotions, sensations, and perceptions are always continuously arising and falling. Intuitively, your idea space is a great example of a topological singularity. It has no direct effect on space-time, it doesn't exert gravity or emit light, i.e. has zero measure, but it exists as an impermanent flow that shapes your entire reality, i.e. it's uncountable. If you're more curious about some of these concepts, then check out the book linked below. That said, the most explicit topological singularity we have is the Cantor Set. Start with the interval 0 to 1, then remove the open middle thirds, leaving the line segments 0 to 1/3 and 2/3 to 1. Keep removing the open middle thirds indefinitely, and what remains is the Cantor Set, an uncountable amount of points with zero total measure. It looks fragmented and empty, yet it contains infinitely many points. It has zero measure because 0 plus 0 is 0, and even if I have infinitely many zeros, it's still going to be 0, which covers the zero measure part of the topological singularity. Next, we move on to uncountability. As we saw in a previous video, uncountability essentially comes down to, for every point that you pick, I can always pick a point that you didn't pick, even if you list an infinite amount. More thoroughly, you cannot list out all the points in the Cantor set by the natural numbers 1, 2, 3, 4. To visualize the Cantor set uncountability, imagine labeling each interval as steps with a sort of a dress code. At the first step, you go to the left and you will have that be 0. If you go to the right, that's 2. If you go down another step, the left interval becomes 0, 0, then you have 0, 2, 2, 0, and 2, 2. You can continue this process indefinitely, going 0 for left or 2 for right. Over time, you build an infinite branching structure of addresses corresponding to points in the Cantor set. The leftmost point contains an infinite strings of zeros, while the rightmost point contains an infinite strings of 2s. Now, try listing these addresses by pairing them with the natural numbers. You'll get an infinitely long list, but just like Misty and the ruler scenario from our previous video, we can construct a new address that differs in 1 digit from every address in our list here. If you go left, I'll go right, and vice versa. For instance, if you go left 0 first, then I'll go 2. On the second number, if you go right 2, then I'll go left 0. Another 2 here, I'll go 0. So on and so forth. By doing this diagonal argument, we create an address not found in the infinite sequence, no matter how long it is. This breaks our ability to list the addresses with the natural numbers, the core requirement for countability, proving the Cantor set is uncountable. No matter how many addresses you attempt to point, I can always address a point that you didn't include. Overall, the Cantor set exemplifies the best example of a topological singularity, an object of zero measure and uncountable depth. Moving forward, this symbol, the Cantor set compressed into a point, which is the trivial solution to connecting the uncountably disconnected points of the Cantor set, will represent a topological singularity. Topological singularities serve as a bridge between abstract mathematics and intangible phenomena. By applying the concept of a topological singularity to our mind, we gain a tangible reference for something that otherwise defies direct measurement. This approach marries a rigorous mathematical framework with key observations of the mind, like the fact that the mind looks like nothing at all and is impermanent, effectively opening new avenues in physics for exploring our inner reality. Topological singularities such as an idea space, a veil of illusion, the Cohen experience, the observable universe during the Big Bang, and the Cantor set reveal hidden dimensions of reality that otherwise conventional measurements wouldn't really be able to find. This reminds us that what appears as nothingness can in fact be infinitely rich. A topological singularity, the marriage of zero measure and countability, shows us that what appears to be nothing can contain infinite complexity. Your own mind or your own idea space is a topological singularity, a hidden dimension of thought and perception that shapes your entire reality. So if you want to learn more about this, check out the book or white paper, both linked below. If you enjoyed this exploration, then consider liking this video, subscribing, and hitting the notification bell so you won't miss any of our upcoming discussions. Next, we'll talk about macro idea spaces, we'll talk about Clopin, and then we'll go into a deep dive on the observable universe at large. So I shall see you then, and until then, have fun! Woo!